Somewhere out in the universe, there might be a shortcut so powerful it could let you cross billions of light years in the blink of an eye, skipping past the speed of light entirely without ever technically breaking the laws of physics. This is the wormhole, one of the strangest and most misunderstood objects in all of science, and what would actually happen if you tried to travel through one is far stranger than any movie has ever shown you. Start with what a wormhole actually is, because Hollywood has almost completely distorted this concept. A wormhole, technically called an Einstein-Rosen bridge, is a theoretical structure predicted by the mathematics of general relativity, essentially a tunnel connecting two separate points in space and time. Instead of traveling in a straight line across the vast, flat distance between two locations, a wormhole would fold space itself, allowing you to punch directly through a shortcut connecting one point to another, similar to folding a piece of paper in half and pushing a pencil through both layers instead of dragging it across the entire surface. Here is the first major problem you would face. While the equations of general relativity technically allow wormholes to exist, nobody has ever actually observed one, and there are enormous theoretical obstacles standing between the math and reality. The most basic form of a wormhole predicted by Einstein's equations, sometimes called a Schwarzschild wormhole, would be violently unstable, collapsing in on itself in a fraction of a second, far too quickly for even a beam of light to pass through it, let alone you. If you wanted a wormhole stable enough to actually travel through, physicists believe you would need something called exotic matter, a theoretical form of matter with negative energy density, essentially a substance that would need to push space apart rather than pull it together the way normal matter does. This exotic matter has never been confirmed to exist in any laboratory or observation, and even if it does exist somewhere in the universe, physicists have no confirmed way of gathering or controlling it in the quantities that would be needed to hold a wormhole open. Now imagine, purely hypothetically, that a stable, traversable wormhole did exist, and you were about to step through it. The entrance would likely not look like the swirling circular portals shown in science fiction films. Based on current physics, a wormhole entrance might actually resemble a sphere, since light and space would bend around it from every angle simultaneously, creating a strange, warped, mirror-like distortion where you could potentially see the destination point reflected back at you from every direction around the opening, almost like standing inside a funhouse mirror stretched across the fabric of space itself. As you approach the entrance, gravity and tidal forces would become one of your biggest concerns, depending entirely on the wormhole's mass and size. A small, stellar mass wormhole could stretch and tear your body apart in a process similar to falling into a black hole, while a sufficiently large, stable wormhole theoretically engineered by a highly advanced civilization might allow you to pass through with gravity forces gentle enough not to harm you at all. This detail matters enormously, because it is the difference between a wormhole being nothing more than a beautiful piece of theoretical mathematics and a wormhole potentially becoming a genuine method of interstellar travel one day. If you did somehow pass through safely, the journey itself might happen far faster than you would expect, potentially even instantaneous from your own perspective, since you would not actually be traveling faster than light through normal space. You would be taking a shortcut around it entirely. This is the loophole that makes wormholes so tantalizing to physicists, because Einstein's theory of relativity strictly forbids anything from exceeding the speed of light within space itself, but it says nothing about shortcuts that fold space to make the distance between 2 points effectively disappear. There is also a genuinely strange possibility connected to wormholes involving time itself. Some theoretical solutions suggest that if one end of a wormhole were moved at extremely high speeds or placed near an intensely strong gravitational field, time dilation effects predicted by relativity could cause the two ends of the wormhole to become desynchronized, meaning one end could exist further in the future relative to the other end. In this scenario, stepping through a wormhole might not just take you to a different location in space, it could theoretically take you to a different point in time as well, an idea that fascinates physicists precisely because it pushes right up against the edge of what current theoretical physics considers possible without directly violating causality. Most physicists remain deeply skeptical that any human being will ever actually travel through a real wormhole, given the almost impossibly restrictive requirements involving exotic matter, stability, and energy. Yet wormholes remain one of the most important theoretical tools available for exploring the outer edges of what Einstein's equations allow, offering a fascinating glimpse into a universe where distance and time might not always follow the fixed rules you experience in everyday life. If your mind is still spinning from that one, make sure you hit subscribe, drop a like, and leave a comment telling this channel what cosmic mystery deserves an episode next, because a brand new video drops every single day right here. Tomorrow, this channel is tackling something even more personal, exploring what would actually happen to your body if you traveled to the center of the Earth. Come back for that one, because it gets far weirder than you'd expect.